Hey, we're live and in person.
Here we
And
go.
feel free, everybody, to chime in. We're being informal. I am going to run a PowerPoint. Let me just see if I can share my screen. No, is that it? Share. Wow, can you see that? Uh,
Yes,
Everyone can see that?
yeah,
Yes.
yes.
This meeting is being recorded. Okay. You are being screen shared. Okay. Look at us. Even after all these years of trying to figure this stuff out, we're actually trying to figure it out. So welcome, everybody. Happy belated Valentine's Day. And did Kimmy's go off to yoga? No, weight training. I don't know. One of the daily health routines that I don't partake in. But so how's everybody doing this winter? Very cold. It's supposed to be nice and warm next week in the balmy 40s, balmy low 40s. I think I burned 5 or 6 cords of wood already this winter. I'm ready for spring, and so are the oysters. So just for folks that aren't familiar with the Marine Center and the whole goings on in the wintertime. A lot of people ask me, well, what do you do in the winter? Do you shut down? And winter is clearly our busiest time. We've already done 2 spawns. We have our first batch of post-set 2025 oyster seed. They're growing as we speak. They're still on heated water. There is no wild algae for them to eat. So we're being eaten. This is when you feel the most like a parent. You remember getting eaten out of house and home. Well, I'm being eaten out of house and home again, even though my boys fled the nest many years ago. But shellfish eat a huge amount of unicellular microalgae. If you were at the last Zoom about algae, their food source, and so they they're being fed every day. Nature is not feeding them, we're feeding them. So between growing algae and doing what we're going to talk about today, the broodstock conditioning and spawning and the larval rearing and all that stuff, we are kept quite busy. If you want to get involved, that's fine, but I will give you the awful caveat, which is I get there quite early. I'm always trying to beat Bart into the Marine Center. He's so far I've only gotten there ahead of him once. But we start, by 7 o'clock, we're really roaring along. And really by 10 o'clock, we're starting to finish putting everything back into water. So the first 3 hours of the morning on Monday, Wednesday, Fridays are really quite busy. And this time of year, it's so cold, there's not a whole lot to do outside. So if you want to get involved this time of year, you have to kind of come to be excited. You have to come early to be kind of what's the word? Not let down, but just bored to show up at 10:30 and there's just cold outdoors to look at. That's no fun. So come early if you want to get involved. And that's only for another month. And then bye-bye, have fun. And then really we're outside again with all the different critters and whatnot. So what I'm going to talk about today, and again, for those of you that are new, and you might even be wondering where we get all of this oysters that we give out to everybody. We do grow it ourselves. We do have our own system for growing everything, and we have been running that for 23 years in the Spat Shack now. And it's remarkable that it actually works, that you can teach the community how to grow shellfish seed, but it's inherently quite mechanical. It's mysterious and magical, but it's also manipulatable. So this is probably the single most wild manipulation that I know, which is to trick shellfish into thinking that it's the season for getting ready for reproduction, and then tricking them into thinking now is the time to spawn. So here's how we do this. Okay. And feel free to unmute yourself for questions. This is an open forum. This is really for your benefit. I actually I was going to say, I know this stuff, but I learn every day. And I was just telling somebody today, my neighbor, who is a chicken fanatic. She's got these 50 beautiful chickens and she's raising chickens. She brought us something like 4 dozen gorgeous, no more than that, lots of eggs today, all multicolored, and the very fancy chickens. And I was telling her how kind of similar, it's animal husbandry, whether it's oysters, clams, chickens, goats. There's a lot to it, and there's has to be a real dedication to it. And so here's the one. I was telling her that, even though I've been growing shellfish for, I guess, 33 years now, it still is fascinating. It's almost as fascinating to me now as it was when I was in graduate school, and really doing this routine, if you will, for the first time. So we're going to talk about broodstock, and we're going to talk about spawning. So what is broodstock? What do I mean by broodstock? And basically what I mean is kind of like a horse. If you were growing horses for racing to make some money, you would hope that your parent stock of this racing stock would be healthy, fit, and maybe have this elusive gene for running like a bat out of hell, or a horse on the back 40. So you're looking for parent stock with traits that might help you along with the goal that you're trying to achieve. And so for us, here are just some things that you could look at with broodstock. We do have the option for messing around a little bit with color morphs, different color patterns and whatnot. More probably important would be to breed in disease resistance. There are numerous diseases in the various shellfish that people culture. And so obviously with any living creature, you would like to think that you could develop a resistance to diseases that can whittle your stocks down. Fast growth, well, this is an interesting one. This is the one that I've been working on for the last couple of years, hoping that I could actually think I'm getting headway with selecting for fast growth. So we'll talk about that in a moment. Known sex. Well, what a weird thing to put on a list here. By the way, I was redoing, this whole series. I've done this series for many years. These lecture series on basically the entire, from beginning to end, on how you would grow shellfish. So we did January's algae culture. Now this is the second one, and we're going to go right through the cycle as we need it as the year progresses. And so this particular talk, a lot of these pictures and a lot of the things I wrote down here were it's like reminiscing with myself, which is very boring. Reminiscing, yeah, I never thought of reminiscing with somebody that you don't know is one thing, but reminiscing with yourself all the time is another thing altogether. So this is a lot of these slides are archival, but the information really hasn't changed. So when I put known sex here, that's because we're going to see that in order to condition broodstock, you can't really just feed and and get ready as many animals as you want. They will really eat you out of house and home. And so this picture in the background of these clams, if this were one spawn of clams, with all of these clams, I haven't counted them, but let's say there's 35, 40 of them. That's a lot of adults to condition for spawning, but you would get also a tremendous spawn. So we'll talk about that. But if you had a limited amount of stock that you wanted to condition, and you knew their sex, you would preferably include more females, because as we will discuss later, shellfish, the males in the shellfish population are kind of like the males in the human population. They're practically worthless. You really only need one good, Charlton Heston type walking around, because it's the female that will make the egg that will make a new being. And the male contributes the gametes, but you can't make a new being without the eggs. So the eggs are really quite important.
Tim,
And so
I
if
have a
you
question
select
here,
yeah, dig right in. There you are, Chris. Hey,
how do you determine the sex of an
we're
oyster?
gonna get there. We're gonna get this. This is only the second slide, for God's sake. Chris, just
I
calm.
wanna
No, as
know.
soon as sex comes up on the screen, everyone gets excited and starts asking all these questions. Don't actually, so I will tell you now, since you asked so politely and I was so snarky. Here's how. Do you want to know how you can tell at a cocktail party, or how you can tell in the laboratory?
Give me both.
Okay, which one do you want first?
Oh, let's do the laboratory. Get that
Okay.
behind us.
Okay, so in the laboratory, and actually, I know this is a teaser, but at the end of this show, I will show you movies to prove this, because I have them queued up. When you're in a laboratory situation and you're spawning shellfish, you can see the gametes being extruded from the individual, and they're either giving off egg and sperm, and you can see that macroscopically as well, and you can determine the sex. Now, in the case of any of this shellfish, pretty much, if you were to then want to keep track of the sex of that particular brood, you could literally mark it for the next spawn. And so if for instance, if this clam spawned and it was a male, you could mark it as a male. This one has a marking on it. We're jumping the gun, but it's fine. So you cannot tell the difference. This is the question when you ask like third graders to tell the difference between a male and a female clam, and you hold up a big clam and a little clam. They'll always say that the big one is the male. It's bred into our darn culture. I'm sorry, but the truth is you can't tell what the sex is of shellfish unless, of course, they're scallops, because then they're both male and female their whole life. But otherwise, you could shuck the animal and look at the gametes under the microscope, and you would see quite clearly that they're either egg or sperm. Now, at the cocktail party, what you do is there's a raw bar going on. You straddle up to the raw bar. Is that somebody has to mute? Somebody has to mute that echo. There you go. That was cool, though. I like that. I like hearing myself with an echoplex. Next time I do a rock concert, whoever that was, I want you to work the soundboard for me. Anyway, you're at the cocktail party, you straddle up to the raw bar, and you say to your compatriot next to you, hey, I bet you I can tell you if this oyster I'm about to eat is a male or a female. And they say, yeah, how? And you take the oyster and you dip your little spork, the little wooden fork spoon thing. You kind of scrape that along the gonadal material of the oyster you're about to eat, and you drop a drop of that in their martini. And if it dissipates and cloudy and milky and is gone, then it was a male. But if it looks like a little Viennese snow goblet, then that's a female. And you know what, Chris, you'll never be invited to a cocktail party again. And your compatriot probably won't eat that oyster either, because now you've talked about the G word and things like that, and you stuck a spork in it. So does that answer your question?
No, I'm thinking when you select broodstock, how do you know that you don't have 40 females in the warming tank?
If you are doing a random pick for broodstock and you pick 40 animals, there is a very, very low chance, but certainly a possibility of them all being either all male or all female. And you would be what they call in the industry, out of luck when it comes to that spawn, because you need at least one male. You need at least one female to get anything out of the deal. So it is random if you go clamming for broodstock and you pull like this many clams that you see here, you don't know how many are male or female. Now, I will tell you what very interesting, a couple of years ago, there were 3 spawns going on right in the neighborhood. Spat was doing a spawn. I think Mike was doing a spawn in his hatchery, and Karen Rivara was doing a spawn in her hatchery. And there was a conspicuously large amount of males and very few females in 2 of those hatcheries. It was like there were no females and there were all these males spawning. And so it was the quintessential neighbor asking to borrow some eggs when they came over, because we had plenty of females. So they came over to borrow some eggs, which, like my neighbor, I do. So now does that answer your question?
So when you select your broodstock, you really don't know how many males and females you have. You just
At the beginning, absolutely not.
okay.
Absolutely not. You can't, because if you were to determine it the other way, you just killed your broodstock by shucking it. So you have to kind of go one season of kind of blind faith. But again, nature doesn't really want to do that. I mean, if the chance of pulling 40 clams randomly and have them all be one sex would be a pretty slight chance.
Okay. Thank you. Thank you.
And you know, I put down at the bottom here general health, and this really came into play in our last spawn. We did a spawn on the 12th. It wasn't on Valentine's Day. It was on the 12th. We did a couple days before. And we ended up getting 3 males and 3 females of 20 to spawn, which isn't a great number. And we shucked a bunch of them. And the general health of the ones we shucked wasn't very good. So this is something we can talk about as we're talking again about how to get a good spawn. Now, color morphs, you probably notice in clams this what we call notada marking. Purple, white, purple, white, purple, and especially here, that's called a homozygous notada clam. Mercenaria is the northern quahog. It's our native hard shell clam. I mean, it's not, when you say native hard shell clam, a surf clam is also a native hard shell clam. So it's kind of a broad statement saying that's our native. But the northern quahog, which is Mercenaria, is our native clam like this. And with this color morph, it's a subspecies called notada. And we can breed this into the system. When it's zigzaggy like a Charlie Brown sweater, that means it's not pure for this notada gene. It's kind of scattered. The genetics is trying to get more purebred, but these are purebred right here, and they're quite designer. They're naturally occurring in 2% of the population. Now, if you say, well, that, I've been clamming my whole life and I've never dug one of these things up. Well, the thing is, if they occur in 2% of the population or around there, every 100 clams that you pull, theoretically, 2 of them should have this ability for this color morph. Now, when you're looking at genetics, and I won't bore you with genetics, but because I practically failed it anyway in undergrad school, college, you have what's called a genotype, which is the genes are coding and it's within the chromosome, and you have the phenotype, which is what you're seeing, the manifestation of the genetics. So this is the phenotype for Mercenaria notata. The genotype, you can have a white clam and it still has the gene that can code for this notata. It's just that it's so recessive that you can't see it, and you have to kind of tease it out genetically. This one here is purebred, so it's been teased out to the nth degree, and so you can get all of your clams to have this marking on them, purebred too. Designer clams. Some people don't like them because they say, a lot of the growers say they don't like them because the shell breaks when you dig them. They say, oh, those purple clams, they're always cracking. And that could be very well because they are hatchery reared seed and are probably being selected for fast growth. So a native clam that might be 5 years old to market size, a notata clam from the hatchery could be the same size in 3 years. So it's laid down shell faster and thus probably a softer or a thinner shell. So now the color morph in oysters, a lot of us are familiar with this black line that runs up the oyster. And, really a lot of our seed has that. And there's kind of a reason for this. Back in 92, there was an outbreak in the Frank M. Flower and Son of Oyster Bay, the hatchery there, of their oysters. They would grow a lot of oysters, many, hundreds of millions of oysters. My understanding is that Dave and Joe used to keep 60 million oysters for themselves, for the company, and everything else they would sell as seed. And in 92, they lost, I believe, something on the order of 90% of all of their oysters to something unknown. And the seed died before it reached the size of a dime, and certainly before it reached the size of a quarter. And after crossbreeding the survivors of that for a couple of years, they discovered that this disease that was killing these oysters, that over generations they were breeding this disease or resistance to this disease into the oyster. And as they were doing that, this disease resistance for what was at the time known as juvenile oyster disease, JOD, they were basically taking the survivors each year of what they got and using them as broodstock. And over the course of maybe 4 generations, they were getting practically no mortality. Might have taken 4 or 5 generations to get to no mortality. Well, it turns out one of the reasons is because JOD is now known as Roseovarus, which is a bacteria. So I think what was going on is that these oysters were developing an antibody for the Roseovarus bacteria. Unlike some other oyster diseases like MSX, which is multinucleated spheroid unknown, or that's Haplosporidium nelsoni, that one is a protozoan parasite that you can't, there's been work trying to breed that out of the system, but it's not really, it didn't work the same way as the disease resistance for roseoveris. And dermo, same kind of thing. It is Perkensis marinus. It's also a parasite that causes the problem. So while they were picking this disease resistance, apparently the brood had a color morph of this line because it transferred with the disease resistance, it transferred this black line. And so a lot of the stocks that you see from Long Island and New York and anywhere that used to get seed from Frank M. Flower and Son have this mark in it. Now, here's the kind of cool thing about this is that what I want to do for next year is I'm starting to see a lot of oysters that are black with the white line. So it's a reverse of this color morph. And I want to breed a batch of reverse just for fun, because you can. Shellfish are relatively simple creatures. What they do very well. And one of them that you can do is this color morph. So scallops, for instance, I love this picture on the bottom right, my bottom right, I guess. Those were scallops that were developed in Martha's Vineyard, at the Martha's Vineyard Shellfish Hatchery. And they were getting these beautiful neon oranges and yellows and whatnot. These are bay scallops, bay scallops, Argopecten irradians. These aren't. These are just other beautiful scallops here, but with a striking color morphs. But the problem with this experiment that they did here, they made these beautiful, gorgeous scallop shells that are so vibrant and so beautiful to look at, but apparently are very easy to spot by airborne predators. So they get snacked up by seagulls at twice the speed of. Now, the one over here, I call them skunks. I think I have a better, so Taylor Bay used to grow live in-shell scallops out of New Bedford, and they would have these gorgeous looking shells that would probably be worth almost as much as the meats that were being sold inside there. They're no longer in business. There's very few people that are culturing scallops. These are ones I worked on this for many, many years. So I call these skunks or peace scallops. They got a little peace sign there in a way. And this is a totally different approach to manipulating a color morph, because this color morph in scallops is actually evolutionarily very valuable. This would be what's called disruptive coloration. So the different rays are really kind of throwing off the whole shape of the scallop when it's in eelgrass or in a darker area. You're starting to lose the shape and the appearance of the scallop shell, and it's becoming more like a zebra. And I suppose a zebra out in the svelte is harder to see than a roan, a red horse or something like that. So that's what that's for. Now, here you go, Chris. I love this picture. We used to do, this is a picture from when I was in the other hatchery. This was almost pre-Spat, I think. And yeah, because 1999, 2000, 2002, and 2003, we spawned this clam. And she is a female clam. How did we know that? In 2000, she gave off egg. No, in 1999, she gave off eggs. And we took an indelible marker and we made the little female sign on there and threw it back overboard at the end of the season, dug it up the next year, spawned again, gave her a break in 2001. But this clam apparently readily conditions and spawns and makes eggs. So this is very valuable to have this tagged. And this one, 2003, 3. So if this was a 2004 spawn, we're really not doing a great job with genetic diversity because we keep using the same clam every year. But you can pull, if you wanted 25 clams and you pulled 15 of them female and 10 male, you would get good genetic diversity and more eggs than not more eggs than sperm, because the sperm is just in the billions of cells. It's just an unbelievable amount of numbers. But in terms of getting more eggs, if you had more females, you will get more eggs. Now, scallops are a whole different critter. And I'm talking about scallops and clams and oysters because I have full intention in the next Spat 5-year plan of growing all three of these again. We concentrate on oysters. We really need oysters to run the program, but we do want to continue to grow all three of these. And I've spent a lot of time with scallops. The fascinating thing about scallops is they're both male and female their whole life. Now, I want you to look at this picture for a second, and I'm going to explain to you triploidy very quickly. But first, what I'm going to do, and I want you to remember this view for something else I'm going to talk about with scallops in a minute, but just to show you the internal anatomy. So here's the adductor muscle. That's the part you eat. Here's the gonad. That would be the roe. And so the white is sperm and the orange is egg mass. So you've got a gut in here. You've got eyes along the mantle edge, the gill structure, and you got a couple little visceral parts in there, but it's really not that complicated of a creature. But look at the difference of these two scallops, and these are shucked on the same moment, so they're the same. It's in real time. And what the heck is going on? Well, what's going on with this is actually these are triploid, which means they've got 3 sets of chromosomes instead of 2. This is a normal diploid. We are diploid. We have 2 sets of chromosomes. This has been manipulated to be a triploid, and I can explain briefly, if we have time, how you can develop triploidy in a broodstock. Well, I'll tell you now. There's a couple ways you can get a triploid. One is by shocking the eggs. You could do it physically. You can do it chemically. And the other way you can do it is biologically, but you would need what's called a quadruploid, 4 sets of chromosomes, a 4N, which you again would be able to do the same way you could get triploidy. You would just be shocking it and harvesting it a different way to get the 4N. Once you have a 4N, you can mate a 4N with any 2N and you will get 3 Ns. The whole point of this, however, see, I don't do any of this stuff. It's if I had the golden goose, which would be a 4N scallop, I would use that scallop, well, for 18 months and then it would die. That's a very short-lived golden goose, boy. But if you had a 4N oyster, a tetraploid oyster that can live 25 years and was female, you would have the golden goose of oysters, because every time that female spawned, you could spawn that with, you could fertilize that with any 2N oyster and get 3N oysters. And what does that mean? What is it? Who cares? Well, what's going on in this picture kind of tells you, in a way, who cares, because a 3N triploid shellfish doesn't put any effort into reproduction. It's sterile. And so all of its energy is going into adductor muscle. And you can see that here. Here's the gonad. Here's the gonad of a ripe in-season scallops. That's what it looks like. At the cost of all the sugars leaving the adductor muscle and going into gonad. So this is for reproduction. Once this scallop spawns, it will recharge and then the adductor muscle will grow. Okay? Does that any of that make sense? Now, here's some brood tanks. So how do you manipulate brood into reproduction? So what you do is this: you take some water and you keep it at spring temperature. So between 20 and 21 degrees, about 70, 72 degrees. You keep, and this is in the winter. This is in January. We started conditioning, I believe it was December 15th. So the water's, freezing, and we're bringing it up to 70 and holding it there for and feeding it cultured algae, because there's no algae in the natural water, and holding that for about 6 weeks. So if you pull up shellfish on January 1st and put them in a conditioning tank and hold them at this temperature and feed them algae for 6 weeks, you should be able to spawn them on Valentine's Day. So January 1st, 4 weeks is January 30th, 2 more weeks, Valentine's Day. So that's how you would kind of gauge it. When you're going to do this, you pull up your adults that you want to get ready for spawning and hold them for 6 weeks at this temperature and feed them. We have to clean the tanks every other day, really Monday, Wednesday, Friday. Charles is doing an experiment with doing a everyday little cleanup to keep the toxins down, to see about that. This is, without doing this technique right, you can't grow any shellfish, because you have to get them to spawn and release gametes pretty much. And I say a maximum of 20 or 30 animals, only because you have to be able to grow enough algae and to feed these things well. They can't be fed marginally. I'm gonna turn the light on. I'm sitting in the dark. Look at that. So, it's better to use a decent amount and size of adults that you want to feed, so that you're not starving them. They really need to eat well, and you need a lot of algae to do that. This is the system that has been rigged up by Spat. And what it is that it's in our algae room, so that what they're doing is they're filling this sump with pretty thick algae, as dense of an algae as we can do for them, and dripping this algae into the tanks below using a peristaltic pump. These are peristaltic pumps. So they're set on a ration, and it's dripping into the tanks, and down below are, in this case, on one side, I'll go back for a second. On one side, they have clams that are going to be the next spawn, and then another batch of oysters. We've done 2 oyster spawns already. Josh is doing an oyster spawn tomorrow, and if he has any larvae, we handed that group off 40 million larvae from our first spawn. The second spawn didn't really go as well as we wanted to, so we still have about 4 million larvae that we're growing, as well as our first spawn post set. So here's clams over here, a second batch of oysters, which will be ready. We just did that on Friday, or we did that on Friday. So 6 weeks from Friday, these will be ready to spawn. Now, I did an experiment with, you remember that picture of scallops I showed you? So I did an experiment with a Spat member on Shelter Island, and we looked at conditioning scallops using light, because why would a scallop have eyes if it wasn't using light for something? And what we found, we did an experiment with 24-hour light, all the other treatments the same, keeping them at 70 degrees, feeding them cultured microalgae, holding them for 6 weeks. But the only difference is giving these down below 24-hour light, the ones on the top 24-hour dark, and another series that was given ambient light and dark. And what we found, which was really fascinating, is when you put scallops in a conditioning tank in 24-hour light, this is what you get. And pay no attention now to the 2N and the 3N. What you got was, with 24-hour light, you got this gonad to be literally more than half the weight of the whole mass of scallops. And in 24-hour dark, you got more than half the weight in adductor muscle weight, which is fascinating. I mean, scallops use light for conditioning. And I don't know anybody that's actually using this technique, including myself, because we don't condition scallops. We don't have enough algae and the time and the equipment to condition scallops in the laboratory. Other hatcheries at Cornell certainly do. It's just a matter of who's going to fund it. So, but this is what we found, which was really kind of what I was hoping, and it's nice that it came out that way. Okay, so now that your 6 weeks have gone by and your shellfish has been sitting in the conditioning tank, and you can literally put this on the calendar. I mean, we have on the calendar our next spawn. Josh has on the calendar tomorrow's spawn, because we gauge it on this 6 weeks. And then what we do is we set up to spawn these things. And what we do is we take them out of the conditioning tank, we put them in a spawning tank. We have all the equipment we need for the spawning tank. So what we have are submersible heaters. If you're in a hurry, you use two. You're taking the shellfish out of the conditioning tank that was at 70 degrees, and you're raising it up to 80, 85 degrees. And what this is doing, and so if you're impatient, you have two heaters. It raises the temperature up pretty quickly. Within 20 minutes, you can go up to this much higher temperature. And I believe, see, what you're doing when you're spawning shellfish is you're really trying to trick them into thinking that they're still in their little oyster bed back home in wherever, in Peconic on Goose Creek, right? So I don't know how many of you have ever gone out in the spring. Do it this spring. This was a pretty cold winter. So when you get a nice spring day and it's just beautiful outside and you feel like going clamming on a nice shallow little clamming spot, low tide, and you go out there and it's May, it's early May, and you go out there and it's a beautiful, beautiful spring day and the sun's beating down on this water, and you go in with your bare feet and you say, wow, this water is so warm. It's like bath water. Well, I think that's also what the shellfish are saying. They're saying, see, we're getting that temperature. You get, because raising the temperature from up quickly is a very powerful enticement for spawning. At least we can manipulate that in the laboratory by raising the temperature up. We do a couple other tricks. So as the temperature is raising up, we bring it up to summer-ish temperature. Now we've got a cool water. We cool it back down. Now, this is where my half-baked voodoo superstitious stuff. So now I'm pretending that these shellfish are actually feeling the tides coming in and out. Everything's good. They're here. You throw some algae in there. It's a nice algae bloom. And you raise the temperature, bring it down. Now bring it back up again. And here's a very powerful cue. Now you take, I call it the sacrificial clam because it sounds religious, sacrificial clam. But it could be an oyster. It could be anything. Here's an oyster. We shuck one. You pick one out of there. You shuck it. And this white, it's going to tell you a couple things. First of all, here's your cocktail thing again, Chris, if you're still here. Okay, yes, you are. This right here is the gonad, this white. This has already been pierced. That's the gut. That's all the green algae they've been eating in here. This was all white. This was very creamy. This has been taken away and put into a little cup here, a gonadal suspension, a little suspension of this gametes there. And now you put that, you can save. So here's the adductor muscle, here's the gills, here's the mantle edge, here's the gonad, and we're washing it into here and putting it in the tank because, and now I don't think this is voodoo at all. I think this is just the miracle of nature. Can oysters talk to each other? Can they talk or can they communicate? There's two different things. Can oysters communicate? Well, when you're out there on the flats and you're sitting there, you just got through the winter, you just spent all this time in the whole of spring getting ready for reproduction. The temperature was right, there was good algae in the water. You got there, that nice sunny day came, and you got enticed to spawn. Well, what happens if you got enticed to spawn and nobody else spawned? Well, then that's the end of your spawn. It went nowhere. But if you could spawn and somehow communicate, hey, I'm spawning, everybody, let's get together, let's wake up. Now, I'm a human, so I have to add the voodoo to this. So we got the floating candle in the tank. We got turns out I've had this rubber gooey duck, which I got from my sister-in-law for Christmas present or something, like 25 years ago, and I've been using it. I've perched that on the table as a good luck icon. So we got everything in place. We have submersible heaters, the thermometers, the cool water hose, the floating candle, voodoo icon, and this one here. Now, I don't care what anybody says. Without the music, you won't get anything to happen. Well, you might. I suppose at certain hatcheries where people aren't having any fun, they don't play any music, but we have fun at Spat, so we play music, and then we wait, and we wait, and we look until you start to see a discharge. And in this case, all of these, I can tell right from this picture here, this was a male, this is a male, this is a male. This one isn't really showing that much here. When you put, this is I call this the men's club. I put all the males right in here and just let them, because the sperm is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 males in here. All the sperm I could decant that in a bucket and I have the sperm of 11 males. That's good genetic diversity. You can see that if you leave them in a beaker, you can lose sight of the whole animal. It'll get that. So in other words, spawning is not a mystery. When they're spawning, you know they're spawning. It's like, oh, gee, are these spawning? No, they're spawning. There's nothing, no other way about it. And if you can see this in nature, which I have only seen once, natural spawning, it's pretty wild to see, because I mean, spawning happens in the water column. Fertilization has to happen in the water column. Once they start spawning, you can put them, you segregate them, because you want to be able to fertilize your eggs. You don't want them to just be enveloped with sperm in a big open tank, or I don't. Some people do. East Hampton kind of does. You can catch all the eggs. This is larvae, but it's just you can siphon down all that water in a 27 micron screen and catch every egg. And you can look under the microscope and you will see fertilization happening. I'll send out some warnings when we're going to do spawns if people want to come by, because it really is quite fascinating. You can see cell division happening. You can see fertilization. Then we put them in the larval rearing vessels where it's going to be about 2 weeks of larval rearing before they finish their larval cycle. This was a spawn that we did in 2006. We had 21 females and 23 males. So a couple things about this spawn that's really remarkable. We conditioned almost we conditioned like 45 oysters. They're big oysters. So we must have had a lot of algae because this would have produced so many larvae. We would have thrown 3/4 of it away the first day. We didn't have the equipment to grow this much. But just to give you an idea, the last spawn, we had 3 females. We've been averaging 10 million larvae per female. So in this case, we would have had 210 million larvae from these females, which is a lot. It's a lot of larvae. How many of it make it? In nature, very few. That's the whole point. This is a numbers game. When you can manipulate this in a laboratory situation, you can really get, I would say, from our first spawn, which we had 7 females. So we got 70 million larvae. We kept 30 million. We gave 40 million away. And, how many seed did we get from what we got? I don't think we got 1 million out of it. It was our first run, but even if we did, that's the first spawn and we get 1 million. Spat itself needs 350,000 oysters to run our group. I like to grow 2 million oysters a year. And so we're going to be spawning shellfish until June. So we spawn a lot of stuff. It would be nice if we could spawn every 2 or 3 weeks. It's a lot of work. If anyone wants to get involved in it, it's really fascinating. I mean, it's just fascinating to think that a layperson, and I include myself as a layperson. I'm not a geneticist. I'm not really a laboratory scientist, but we as a group can grow oysters from scratch, which is really quite fascinating. I mean, and it works. We do it all the time. And so it's not like, wow, we did that. Isn't that cool? I wonder if we'll ever do that again. We do it all the time and we share it and it's fascinating. So if anyone wants to get involved, again, the only caveat, it's not that you can't come around later, but if you really want to get as part of the group, then you just got to freaking wake up early like I do. It's not that I really like to, but it is. No, I do, because it's fascinating. I look forward to getting up early and going and looking at. If I was raising cattle, I don't think I'd be as excited, but these are mini cattle. They're so tiny. You can actually pick up 1 million of them in a cup this big. So that's kind of cool. And then they grow big and fun. And oysters are going to be good. It's a good time for shellfish. So I encourage anybody that wants to come by to dig in. And the season's just starting up as far as everything else. I think we're going to get through this winter pretty soon. I made an oyster stew from oysters I pulled out of the Marine Center today. That's just unbelievable. So oysters are doing great. They love it cold. They love cold winters. So don't worry about your oysters. They're doing just fine. But do worry about yourselves. Don't go out and harvest oysters and fall through the ice. Okay? I noticed ice on Goose Creek. Oh my goodness, where you are, there's ice there.
There's a lot of ice.
Yeah,
Yes.
I noticed it today on my way over there. Over this other side of the bridge is pretty well frozen.
This is the second round of ice like this. And I think of it like the second time it's frozen along the shoreline the way it is. And I
It's
am
fine.
nervous.
No, it's gonna be gone, but it's gonna be gone by next week. It's very fast moving there. It'll break up and be gone by next. It's supposed to be in the 40s next week, so we'll be all right.
That'll be great.
Good. Well, everybody, stay in touch, and I'm not sure what the what the status is on this spawn tomorrow. There will be a spawn in the big hatchery tomorrow. I suppose people can come by and check that out. I would usher you in that. It's not our spawn, it's the other groups, but we'll find out. Darcy might know. Is that planned for tomorrow with anybody, with any dignitaries or anything, or nobody knows? Darcy? Darcy? You're right there, Darcy. She can't hear me? Can anyone hear me? Did I lose everyone?
I hear you. We can hear you.
Oh, look it. I forgot about this. Let's see if this works. Oh, here's a button. That didn't work? Oh, you know why? That's funny. Whenever you're doing a PowerPoint, I could fix it. Let me see if I can just fix this. I bet you anything, whenever you're doing a PowerPoint and you want to play videos on it, if I'm not mistaken, you have to, where's my, hold on. Let's try this. You still seeing that? Let's try this now.
That seems to be working. Did you need
Yeah.
me? I heard I was in the other room.
So that,
Awesome.
Yeah, I can see that.
so that's an obvious discharge. I mean, that's not a mystery. That's a female. You can see when I say the Viennese snow goblet. So I think it's more like Crest toothpaste, but it's very grainy. You can see the graininess, whereas this one here, that's also that's another female. Here's a male. It gets smoky, doesn't stay. This one's very grainy. That's a female. But the point of that is, when these things are spawning, it's not a mystery. I mean, it's mysterious as all get out, but it's not like, gee, are they spawning? Yes, they're spawning. There's no doubt. There's no doubt. So that's what it is. Okay.
Wow.
So that's it. Anything else? Darcy, are they planning anything for this spawn tomorrow? Do you know? Oh, she left again. Oh, that's okay. Anyway, we'll be there. I'll be there. I'm doing drain down tomorrow. I got the little oysters to play with. If you want your 1,000 oysters, you can come and get them tomorrow. They would be you could fit 1,000 probably in, let's see, 1,000 probably in, I mean, not a shot glass. That would be like 100,000. Probably be more than that. They're so small, but if you want to look at them under a microscope, you can start naming them. That's
Hey,
fine.
Kim, were you asking about tomorrow?
Yeah.
Yeah, anyone is welcome to come to the spawn. Josh, it's going to be in the big hatchery and it begins at 9:30 and everyone's welcome.
So, well, there you go. So you got the inside scoop from the boss there. Good, good, good. I hope that doesn't mean I got to show up. I got work to do tomorrow, 9:30. No, but do come by. If you're interested in what you saw today, you could very well be able to see it live tomorrow. And and after that, and this is Chris, we're playing Pookaberry with the jazz quintet tomorrow. So we're playing Pookaberry at 6 to 8 with a jazz quintet. That's no charge. So if you want to go, I don't know, how's the food there, Chris, in your opinion? You can stop recording, Darcy.
It's eclectic, to say the least.
Well, yes, that's a given. The place exudes